Have you ever heard a weird little buzz from an outlet? Or maybe you've seen a tiny spark flash where it's not supposed to? Well, those are clues to one of electricity's biggest secrets, and today we are going to uncover the shocking truth.
You've probably heard grown-ups use the words short circuit, right? Usually, it's when some gadget suddenly stops working. It sounds kind of serious, but what does it actually mean? What's really happening in there? Let's figure it out.
Okay, so before we can understand what goes wrong, we first have to see what a circuit looks like when everything's going right. So, let's start with electricity's happy place, its normal, everyday path.
So here's the number one thing you got to remember. For electricity to do anything at all, it needs to travel in a complete circle. Think of it like a racetrack. This loop is called an electrical circuit. It flows out from a power source, like a battery, goes through something it powers, like a light bulb, and then goes right back to the start. And this picture shows that loop perfectly. Just look at it. You can see the wire makes a totally complete path from the battery, through the lights, and then all the way back. As long as that road is unbroken, the electricity just flows along and boom, the lights turn on. That's a happy, working circuit.
A really easy way to picture this is to think of that wire like a highway. The electricity is like a tiny car that has to drive the entire route. It has to go through the town, that's our light bulb, to get its job done and finish the trip. No shortcuts allowed. But what if that little car full of electricity spots a brand new exit ramp, one that lets it skip the town completely? What happens when electricity decides to get a little bit lazy? This is where things get really interesting.
So, here is a super important fact of science. Electricity is all about taking it easy. It will always, and I mean always, choose the easiest, smoothest path it can find. We call this the path of least resistance. It's just like how you'd rather walk on a nice, smooth sidewalk instead of wading through a bunch of sticky mud.
And look at this. This picture shows that rule in action. See that new wire? That's the shortcut. It completely goes around the light bulb. The electricity, which is always looking for that easy route, just drops what it's doing and zips right down this new easy-peasy path.
And that, right there, is a short circuit. It's when electricity finds an accidental, super easy path that lets it skip doing the hard work, like lighting up a bulb. It's not always a shorter path, but it's always an easier one.
Okay, so talking about it is one thing, but seeing it for yourself makes it so much clearer. Let's walk through a really simple experiment. And hey, remember, if you ever try this stuff, make sure you have a grown-up helping you out.
All right. First up, we just make our normal happy circuit. We connect a battery to a bulb, and ta-da! The bulb lights up. Easy. Now for the fun part. We're going to take another piece of wire and just touch the ends to both sides of the bulb holder. We're basically offering the electricity a brand new shortcut. So what do you think's going to happen?
Poof, the light goes right out. The second you give it that shortcut, the electricity basically says, see ya to the light bulb. It completely ditches the tough path through the bulb and just rushes through that new easy wire instead.
And it all comes down to this really simple idea. As one of our sources put it perfectly, the wire created a short circuit. It just took an easier path of low resistance. So it's not about how short or long the path is. It's all about how much of a struggle it is for the electricity.
So the light bulb goes out. Big deal, right? Well, actually, that easy path can cause some really big, really dangerous problems. This is why we need to take short circuits seriously.
This little chart explains everything. In a normal circuit, the light bulb puts up a fight. It has high resistance. It's like a traffic jam that slows down the flow of electricity, or what we call current. But in a short circuit, there's almost zero resistance. It's like a giant 10-lane highway with no speed limit, and that means you get a huge, out-of-control rush of electricity.
So what happens when all that energy goes rushing through a tiny little wire that wasn't built for it? It creates a ton of heat. Seriously, you know how you can rub your hands together really fast to warm them up? Imagine doing that 1,000,000 times faster. That's the kind of crazy heat we're talking about. And that extreme heat is what makes short circuits so dangerous. It can literally melt the plastic coating right off of the wires. And when that happens, you have bare, super hot wires that can touch things, create dangerous sparks, and those sparks can easily start a fire.
I know that all sounds pretty scary, but don't you worry. Our homes are actually designed with all of this in mind. We have these awesome built-in heroes that are protecting our electrical systems all day, every day.
So let's meet our heroes, fuses and circuit breakers. You've probably seen a circuit breaker panel in your house or apartment. It's that gray metal box with all the little switches inside. Well, those are the guardians of your home's electrical safety.
And these things have one simple job. They watch for that dangerous rush of electricity. The split second they sense that huge surge from a short circuit, they jump into action. They do exactly what their name says. They break the circuit. It's like flipping a switch that opens up the highway, instantly stopping the flow of electricity before anything can overheat and start a fire.
Okay, let's do a quick recap. Here are the 5 key things to remember. 1. Electricity needs a complete circuit, a circuit, to do its job. 2. It's always going to take the easiest path it can find. 3. A short circuit is just an accidental, easy path that lets electricity skip doing its work. 4. This shortcut causes a dangerous rush of electricity and a whole lot of heat. And finally, number 5. Fuses and circuit breakers are our safety heroes that stop that rush in its tracks.
So, we've learned all about the cool safety gadgets that protect our homes from short circuits. But that leaves us with one last, really important question to think about. What protects you? The answer is being smart and being safe. And now you know a whole lot more about how to do just that.